Hello student, today we give a lecture on integration. So what is the concept of integration? What is the definition of integration? Mainly, basically there are two types of integration. First of all, first is indefinite, indefinite integration, and second is definite integration. Okay, so before going to integration, indefinite and definite, we have to know the sign of integration. So this is the sign of integration, and with f of x dx, this is called integration of f of x with respect to x. Okay, now first we have to know that we have to study that what is the indefinite integration. So let f of x dx, this is equal to, the definition says that the collection of all primitives of f of x is the indefinite integration. So let us take a function phi x such a way that dy dx phi x equal to f of x, that is phi of x is a primitive or antiderivative of f of x, then phi x belong to this set. Again, let us take another function phi of x plus 1, then dy dx phi x plus 1 is f of x, so phi of x plus 1 also belong to this set. Again, phi of x similarly plus 2, this belongs to this set, and infinite number of terms. So if we write this is a general set, if we write in general, then this look like as phi of x plus c, where c is arbitrary constant and dy dx phi of x equal to f of x. So this is the main concept of indefinite integration. Now, what is the definite integration? What is the definite integration? So if we add two things, that is, if we add x equal to a lower limit and x equal to b upper limit, then this is called definite integration. But what is the concept of definite integration? What is the geometrical meaning of definite integration? Now we discuss here. So let us take a two-dimensional graph, xy plane. This is x-axis, this is y-axis. Now this is the function of f of x. Now x equal to a is the line parallel to y, x equal to b is the line parallel to y, and y equal to 0, that is x-axis. Now the area of this region is give the definite integration. Okay, this is the main concept of definite integration. Now back to indefinite integration. In this class we mainly discuss indefinite integration. So there are three properties of indefinite integration. First is, if we derivative of integration of f of x dx with respect to x, then we get f of x function, that is this integrand. Here f of x dx, integration f of x dx, f of x is called integrand and dx is called element. Okay, now second property is integration over c f of x dx equal to c into f of x dx, integration f of x dx, where c is an arbitrary constant. Now 3 is integration f1x plus minus f2x. f1x and f2x are two function of x, then this is equal to integration of f1x plus minus, here is dx, and integration of f2x dx. So this is the main three properties of integration. Now we going towards the fundamental integration formula of integration, which help us to calculate the integration on over any function. Okay, so first is x to the power n dx. This is equal to x to the power n plus 1 by n plus 1 plus c. C is arbitrary constant. Second is, and n not equal to minus 1. Okay. Achha. Then 1 by x dx equal to log mod x base e plus c. Now third is integration a to the power x dx equal to log, sorry, this is equal to a to the power x log a base e plus c. Now fourth is, if we put here, if we put a equal to e, then we get e to the power x and log e base e, and log e base e equal to 1, so we get e to the power x plus c. Now fifth is integration sin x dx, that is equal to minus cos x plus c. Now sixth is equal to integration cos x dx, that is equal to sin x plus c. Okay. Now next formula is integration dx by x square plus a square, that is equal to 1 by a tan inverse x by a plus c, and here c is an arbitrary constant. Now we going towards a method that is very important in integration, indefinite integration. So this method name is integration by parts. Okay, so when we use in this method, that is integration by parts. Now let f of x, integration f of x dx, we calculate this. Now usually if, sorry, if fx is a function of more than one type of function, that is ux into vx, then we use this method, integration by parts. Okay, now here we have to choose one as a first function and other is second function. Now first of all, what is the rule of by parts? So the rule is u v dx is u v dx, that is first function, then integration of v dx second function, minus integration first function derivative and then integration of second function, and then all integration. So this is the main rule. Okay, so now the question is how to choose first function and second function. So the answer is, there is a method, there is a rule. The rule is, the rule name is, rule is I L A T E. I means inverse function, L means logarithmic function, A means algebraic function, T means trigonometric function, E means exponential function. So if here u and v is the function multiplication of two functions, if u is a, let us consider if u is a trigonometric function and v is a inverse function, then we have to choose v as a first function and u as a second function, because here I is first letter and t is fourth letter, so I becomes first and then becomes t, so v is the first function and u is the second function. Now take an example, sine inverse root x minus cos inverse root x by sine inverse root x plus cos inverse root x. This is the previous year's question. Now how to solve? First of all, we have to know this value. This is pi by 2, so this becomes 2 by pi integration sine inverse x root x dx minus 2 by pi cos inverse root x dx. So our main motive is find the this integration. So integration sine inverse root x dx. Put x equal to sine square theta. Why we put x equal to sine square theta? If we put x equal to sine square theta, then here this root x becomes sine theta and sine inverse sine theta becomes theta, and then we put dx, value of dx. So what is the value of dx? Dx by d theta equal to 2 sine theta cos theta. So dx is equal to 2 sine theta cos theta. So dx equal to there d theta sine 2 theta d theta. So this is equal to becomes theta sine 2 theta d theta. So here involves two functions or more than one type of function. So we use by parts. So this is algebraic function and this is trigonometric function. And rule is I L A T E. So algebraic, here algebraic A letter is first and then T, so trigonometry. So we let choose theta as a first function. So theta, then sine to theta minus d by d theta theta integration sine to theta d theta d theta. So this becomes theta by 2 cos 2 theta minus plus minus and minus plus, and then 1 by 2 this cos 2 theta d theta, and this is equal to minus theta by 2 cos 2 theta plus 1 by 4 sine 2 theta plus 3. Now we put value of theta. So from this we get sine theta equal to root x. So theta equal to sine inverse root x, and we put this value here, then we get the value of this. And next similarly we get this value. So how to get this value of this integration? We put x equal to similarly cos square theta, then we get the value. So this is the main concept of integration. Now what is the summary? So we today in lecture we know that what is the main concept of integration. That is, there is a first of all there are two types of integration: definite integration, indefinite integration. In this lecture we mainly discuss about indefinite integration, a little bit more definite integration. Okay, so indefinite integration is the set of all of its primitives. Okay, that is antiderivative. This is the uh, semi indefinite integration. Now then we study three properties of integration, then some formula, and then we study the uh, important part of this integration, that is method of integration by parts. This is the very important topic. So this is the lecture. Thank you.